Hello, this is Zach, and in this video I'm going to be making a tutorial for how to make an interactive application using RPGLE. So this is going to be a really simple application. It's going to be geared towards beginners to RPG. So this interactive application is just going to be used to solve the area of different shapes. So it's going to be really simple, but the main goal is to kind of understand how to make the display file with the screens for the application and then the RPG program that controls the interactive application. So an interactive application is going to be user driven. So as the program runs, the user interacts with the application, and the sequence of instructions that the program executes is going to in part be determined by that user interaction. And this differs from batch processing, since batch processing and during that, a computer processes a batch of data without any user intervention. So that's kind of the difference between those two uh, types of programs. So first I'm going to start out in SU and I'm going to start making the display file. So I'm going to do work member PDM and F6 to create our display file. So this is going to be called app screen and this will be type display file. And to start out, I'm going to prompt this and press 1 on functions because the first thing that I want to do is use this. And so this is going to be used, places the option and response indicators in a separate buffer. So this is going to be used in the display file to organize all the indicators used in the display file into their relative positions in a data structure. So that's what we want to put in our first position here. So in Dara. And then after that, we want to specify that we want to use um, command keys, so our F keys. And that's going to look like this. So what does this mean? So our CA here, our CA03, this is establishing that the F3 key is a valid function key in our application. So this is saying that we want to be able to use F3. And in our parentheses here, this 03 is associating the indicator 3 with our F3 key. So when we press F3 in our application, it's going to turn on our indicator 3. And this is just a bit of text explaining that. This isn't necessary, it's kind of optional, but it's best to keep it there so that we kind of understand what's happening. So I'm going to copy this and paste it on the next line. And I'm going to do the same thing with function key 12 and indicator 12. And we're going to be able to have two function keys, one for exiting and one for canceling. And usually would be for going back one screen in our application, and then F3 would be to close it all together. So now that we have that, we can start making our first screen. So I'm going to prompt this and be a record format, and we'll make it, this will be our first screen, so I'll call it screen 1 format. And that's it for that. And so we're just going to put some headings on our screen. So what I'll do is prompt this. And on line 2, in position 25 on that line, I'm going to put some text. And it'll say find the area of a shape. And I'm going to keep putting more text at the top of our screen. So I'm going to tell the user to choose one of the shapes, but I'm going to move to the next line here. Don't worry about the messages. So choose one of the following shapes. And then I'll close my parentheses. Oops, I accidentally pressed. Okay. And so we're going to list out all of the shapes um, that they can choose from. So I'll put square, triangle, and then we'll move to the next line. It's a little tedious, but we can do it. And we'll do rectangle. So we'll just do 3 for now, and you could always add more later. So that's that. And so now we want to get our input from our user. So I'm going to prompt them with another message. On line 7 in position 3, we'll say find the area of A, and then we'll get some input from our user. Oops, meant to put this. Get some input. So that means we want to define a variable. And that variable will be called entry. And I'll prompt this to, it's going to be a character of length 10. And we'll use it for both input and output, even though we probably will only be using it for input, but just in case we want to do something with it. And so we'll put this on line 7, position 23. So that's all we want for that. And we also, I'll put some lines for messages for if we want to send a message to the user. I'll make that a length of 60, a character. This will be an output field on line 10. And I put that in the wrong spot, 10 and 10. And then I'll just do another one. I'll just copy this to make it faster. I need to. Okay, and change this to message line 2 on line 11. And so that's what our first screen will look like. And so I'm going to do File to save that. And we've saved that. And now I'm going to open this up in Visual Studio. That was really just to get our columns for our display file. So I refreshed our object browser in Visual Studio. I'm going to open up our DDS source file, and I'll open up this. So in Visual Studio, there's actually a cool feature where you can preview and you can see what your screen's going to look like. So we can see find the area of a shape, choose one of the following shapes. We have our options, and then we have our input field and our output fields. This is both input and output. So now we can start on our first screen for finding the area of one of our shapes. And we can choose to do the square first. So I'll say square format. And then we want to prompt the user. And I'll say enter a length to find the area of a square, because we just need the length to find what the area is. And then we'll create a variable. We'll say this is length, kind of shorten it. And so here we'll make this a length of 10. We'll make it a zoned with 2 decimals, and it's an input field on line 5, position 20. And so that's really what we'll need. Oh, I forgot to write the message that says length. So here on the same line, we'll say that this is length equals. So we'll say length equals, and then our input field. So enter length to find the area of a square, length, and then we have that. Sweet. And so we can just go ahead and make our other screens. We only need 2 more. So this will be, instead of square, triangle, but we'll just do this. And so for triangle, we need base and height. So we'll say enter the base and height. To find, we're going to move this to the next line to find the area of a triangle. And then we'll say this is the base. You need to move it so they're in the right position. And I'm just going to copy this to get the height. I forgot the A. And we also need to move this to the next line. And this needs to be for a triangle. So I'll say TRI. This will be height TRI. Sweet. So that's our next screen. Enter base and height to find the area of a triangle. And this is super simple, but it gets the job done. We have our two input fields and we have our labels. Great. That's all we need. So I'm going to copy this one and do this for the rectangle. We'll say rec, and we'll just leave like that. So for this, we need the width and height. So we'll say enter the width and height to find the area of a rectangle. Change this to width. Oops. And this will be width rec. Make it line up. I'm going to make this a capital just to keep with the format. And this will be height rec. Great. So we have all of our inputs and our labels and our prompts. So this is really all we need for our screen. Or our screens, I should say. So one thing to note that up here, we have this specified above all of our record formats. So that means we can use our F3 and F12 key in all of our different screens. If we were to specify these right underneath our record format, it would be available within this record format. And then if we went to a different one, it wouldn't be available anymore. So you can either specify them specifically in each record format, or at the top, it's available to all of them. And I'm just going to make it available to all of them. And so actually, that being said, I want to, at the bottom of the screen, write a message that says that they can use those. So I guess on something like line 20, position 20, we'll say F3 equals exit, and then F12 equals cancel. And so we can see we have those there. So now the user knows that they can use those function keys. And so I'll just put that on all of them. There we go. And there we go. The prompt is, or the preview is really nice, so we can see that. And so in here, I'm just going to do this, but they really only need one option, because if they press one of them, they'll leave. I'll just put F3 to exit. Okay, sweet. So now we're ready to compile this. So we have to save, Control S, and then we'll say create display file, making sure that we have our library that we're using in our library list over here. And I guess I'll show you can edit this by using the change library list icon here. And so if you needed to type any of them in, you can do so. It's weird that that didn't show up with mine in there. But anyways, current library. Okay, and so I'll compile this, enter, and we see the action created display file was successful. Great. So now we can move on to our RPG program. So I'm going to hit this new member. I'll call this area solver dot RPGLE. Cool. And so in the first line of our program, I'm going to put, I'm going to put star free. and that's going to indicate that we have a totally free format code in here. And then, oops, and then we're going to declare our file next. So, and this is a workstation. So work station. And then, so in our file declaration, for the display file, we want to include the keyword indds, and then we'll name a indicator data structure in this position, which we'll declare after this. So we'll just call it indicators. And so this is going to move the indicator area from the DDS into the data structure in the RPG program. So in here, we specified this INDARA. And so this is going to move our indicators into this indicator data structure. And so let's go ahead and declare that data structure. Declare DS. And name it the same thing. And so we had two indicators that we needed to declare, one being exit indicator in position, sorry, I want to capitalize it all, in position 3. We can just put 3. And then cancel is an indicator in position 12. So here we have our indicator that is linked to our F3 key and our indicator that's linked to our F12 key. So once we press those, these will turn on if they're pressed. Okay, and so now we also want to declare a variable for our result value. So we'll declare a standalone variable result, and we'll make it a zoned 20 with 2 decimals, and we'll initialize it. And so now we can start writing our main for our program. We'll start by doing a do while loop. So we'll continue to loop while our user has not pressed exit. So while they haven't pressed the F3 key, we will continue our interactive application, and then we'll end our loop after that. So this is going to be the main loop of our program. If the user ever hits F3, then it'll end, and then we want to end our program actually. So what we'll do is we'll turn on our last record indicator and turn that on. Then we will return control to the calling program. And so that's what we'll have there. And then underneath this, we'll put our subroutines, but for now, I'll start by displaying our first screen. So the first thing we want to do is indent, and then I'll put this comment that says display first screen. And so we're going to do something called execute format, and we'll execute the format for our first screen. And you can see that Visual Studio has given us the option just to press tab on that. And so the execute format is going to write to the screen, and then it's going to wait for the user's input. So it's going to execute our screen and then wait for them to either enter a value or press one of our F keys. So after we do that, if the user, oops, all the way over here, if the user hasn't pressed the exit key, so if not exit after our execute format, then we are going to try to go to one of our next screens. So how do we make that decision? So we can do something called a select statement. And in the select statement, there are multiple cases. So in these cases, we'll say if they enter square, triangle, or rectangle, and then we'll execute that format for that screen. So what we'll say is when the entry is equal to square, and it'll be all capital. In green screen, everything will be capitalized. But if I wasn't expecting a fully capitalized entry, then I might use something called %2upper, which is a built-in function that will take our entry and make all of its characters uppercase. And that's a way of validating to make sure that it's always going to be we're always going to know what we're expecting here. But what I am going to do is use the trim built-in function to get rid of any extra spaces in our entry, and then it will look like this string right here. So once we do that, we can execute our format. Execute format for square, and it's going to give me the option to select it. And so there, we execute that format, and then if the user doesn't press exit and not cancel. So if the user doesn't press exit and if the user doesn't press cancel, we'll continue on and we'll call a subroutine that does the calculation for that finding the area. So this will be our spot to call a subroutine. And so I can do this for all of our different screens. And I always like to end our select statement before I forget. End select. So that's all you do for that. And so I'm just going to copy this and then do this for all of our screens. So triangle, make sure I spell everything right. And then so this will be, instead of this, it'll be triangle format. And then we have our one for rectangle. Make sure this is rectangle format. There we go. And in our select statement, we can have a default case which is specified by other. So if they enter anything other than these words, then we can perform a different action. And so if they do that, I'm going to write to my message line and say, you didn't enter anything that I was expecting, so nothing's going to happen. I'm not going to say that specifically, but I'll say invalid entry. So we'll just say that they didn't enter anything valid. And so there we go. We have kind of the main logic that's going to control the flow of our interactive application. So now the next thing we need is our subroutines that's actually going to perform that logic. Luckily for us, the math is not very difficult, just finding the area of a couple simple shapes. So when we write a subroutine, so once we call our subroutine, our it's going to start executing lines in a different portion of our code. And so I'll show a demonstration of that once we finish here. But once we call our subroutine, it's going to start executing down here. So begin subroutine, find area, find square area. And then we'll end subroutine. And so in here, we'll do a calculation. Result is equal to length of a square times length of a square. Length times length is the area. And then so in our message, we're going to write a message that says the area of a square with a length of, and I don't want to run out of space here, so go to the next line. Might as well use our next message variable. So the area of a square with a length of, and then we're going to put the entered value into here. But this entered value, you can see, is a zoned, and we're expecting a character. So what we can do is convert our zoned data type into a character by using the built-in function char. So we can say char length, and then we'll concatenate that with the rest of our message that we want to write. So length char, so the length of area of a square with a length of the value is, and then we'll write our answer, which is our result, converting this with char result. And I guess at the end we'll say um, units, some measurement of units. There we go. And there we go. And then if we do this, we might as well just blank out our entry. So we'll turn that back to um, empty. So the entry line will be empty again, ready for the user to enter something else. And so I'm actually going to put a comment here. It's always good to write comments throughout your program. So this will say uh, calculate area of a square. Super simple, but just so you don't have to look at what's actually happening to know. And so I can just copy this and I'll use it for our next subroutine, making sure to change this to say triangle. And instead of these, we want to do the base and height. So we'll do base of a triangle, height, and we'll pick the correct value. So the area of a triangle with a base of, and we'll put this up here so we have enough room. Um, Base of this, and we'll put one another space, and a height of, so the area of a triangle with a base of our base value and height of height value is result in units. There we go. And we blank out our entry. So that's all we need for that. And then area of a triangle. Make sure we change everything if we copy. Can't be lazy if you copy because then you'll get caught for copying. And I just lost my window over here. Okay. Calculate area of a triangle. So we'll say this is rectangle, rectangle, and this will be width and height, right? Width of a rectangle, and then we just need to change this to rec. So the area of a rectangle. I swear this will get more interesting once we actually run our program. With a width of, and this will be width and height of this. So the area of a rectangle with a width of this and a height of that. Let's make everything capital for some reason. Is this many units. Great. So that, for the most part, is going to do what we want it to do. The only thing we could add is blanking out our messages once we progress to another screen, but I guess we'll just show this for now. I'll go ahead and save that, and we'll compile it and see if we had any errors. Create bound RPG. And so we were successful. We did that. And so we get a message here, but we don't worry about that. It has a severity of 0. And in the terminal down here, we can see some information that usually would be in our spool file in green screen. Okay, let's jump over to green screen, and we'll go, we don't need to go to, we can just go call, and then our program's name was area solver. And I don't think I have my library list set up, but we'll see. Okay, so I needed to edit my library list to make sure I have my library in it. So I need to do edit library list. That's without an I. And in here, I'm going to put my library. And now we can call area solver. There we go. So here we go. We're on our first screen. Find the area of shape. We have our prompts. And so we can enter something like square, press tab and enter, and we go to our next screen. So we can type in a value of 100. And since we have two decimals, we need to write those decimals afterwards. So this is 100. Do tab and enter. And we didn't get anything. Nothing happened. So let's see why. Press F3. And I have a feeling it's because we didn't enter, we didn't call our program, we haven't called our subroutines yet. So let's go ahead and call our subroutines. So we'll execute subroutine, and then the names of them were find square area. So that was for square. Execute subroutine, find triangle area, and then lastly, execute subroutine, find rectangle area. There we go. So let's go ahead and compile this. That was a silly mistake. Hopefully you caught that. Bound. Here we go. So now once we call our subroutine, once we hit this line of code, it's gonna call our subroutine, and we're gonna actually move all the way down here and start executing our lines of code down here. And then once we complete this, we're gonna move to our next line of code and continue on in our main. So that's kind of how control can shift within our program. So let's go ahead and green screen and call this again. Press F9 to bring our command back. And we can go back to square, hit enter, and we'll go ahead and put 100 again with two decimals. And now we actually get our message that says the area of a square with a length of 100 is 10,000 units. Nice. And so now what we can do, try out the other ones, triangle. So we can say a base of 50, height of 600. Let's put a decimal to make it interesting, 50. Hit tab and enter. And so we get the area of a triangle with base of 50, height of 650 is this value. Great. Might as well test our rectangle. And we'll do a width of 8,000 and height of 10. Tab and enter. Area of a rectangle width of 8,000, height of 10 is 80,000. So there we go. And so also to show our command keys, I'll go into square, and if I hit enter and I type something like 100, I'll hit F12. Oops, I meant to hit tab first. So if I hit tab and then F12, we move back one screen. And so we get all of our values that were still on that screen because we haven't blanked any of them out. And what we can do also, say if I do square again, and then if I hit F3, it's going to exit our program completely. And so I'm actually going to put this in debug and show that happening in real time. What I would do is add in clearing the messages and stuff, but I guess I'll let you do that. Figure out where you might want to add that. I have a feeling it would be somewhere after we execute the screen. Might want to clear out some values so that the next time we iterate, it will be clear. And if we go backwards, the screen will be clear, something like that. So I'll let you clear out the message lines and the entry because the entry is only being cleared if we actually execute one of our subroutines. Okay, so let's go ahead and put this in debug. So to do that, we do start dbg and the name of our program, area solver. So we hit enter and it shows us our program. So if we wanted to, we could put a breakpoint in here with F6 and then we could jump to that. but I'm just going to press F10 to step, and then now I'm going to call our program. It's ready to be debugged. So here we are. So I can step through this with F10. And so if you don't know, debugging basically allows you to execute the program line by line, and you can get a good idea of what's happening here. And you can do things like press F11 to see the value here. So we can see that both of these indicators are turned off with the 0. And you can see what the result is, which it's just blanked out because it's initialized to a default value. So we can press F10 and we start in our main, which would be our first loop here. So do while, not exit, and it is off. So we continue and we execute our format. And then we come here. So once I type in something like triangle, tab, and enter, I'll press F, and I'm just pressing F10 right now. So we go to our select statement, and it has to determine if we entered a valid entry. So it wasn't, and we can see here entry, if we do F11 here, we can see entry is equal to this, and we see these two spaces here. So that's what our trim is removing to make it equivalent to whatever our expected values are. So I'll keep pressing F10, and it's going to do this statement where it checks, and it is true, so it goes inside and then it executes the format. We can enter some values, 100, 200, tab enter, and then it will go, and if we didn't hit cancel, this is both true, it checks this has to be true and this has to be true. So both of these conditions need to be true to continue, and since they are, we call our subroutine, and this jumps all the way down to where we have our subroutines. And so we can see if we press F11 here, we can see the value of our base, and we can see the value of our height. And something cool we can also do is if I press F9, we can say eval height triangle, and I can actually set this on the fly to something other than what it is. So this was I can't remember what I typed in originally, but I know it wasn't 700. So if I type equals 700, we just reset the value from whatever it was before to a new value. So if I do F11, now this value is, oh, actually it's 7,000. Since I'm not entering it on the screen, I didn't need to put the two zeros for decimals, but that's okay. So yeah, that's how you set something on the fly. So you can debug a program, and if you need to change a date or a time or something like that, you can go ahead and do that like that. Anyways, continuing onwards, we set all of our values, and we see entry is equal to triangle, and then after we execute that line of code, now it's equal to nothing because we blanked it out. Cool. Then once we do that, end our select, end our if, end our do. Since we haven't hit the exit, we go back to execute our main screen, and we get our message. The area of triangle base of 100 and height of 70,000, or yeah, 70,000 is this value. So that's kind of all that I really wanted to show. And so I'm going to go ahead and hit F3, and since I'm debugging, we'll show that the first thing we do after we execute our format is we check if this isn't, if we didn't hit the F3 key, and since we did, this is false, and we will exit our loop, turn this last record indicator on, and return to our main screen. And to end our debug, we do end dbg. Oops, end dbg. So that's that. So just to go over the structure of this again, we have our file declaration with our indicator data structure. We declared our indicator data structure here and named our indicators, which are pointing to indicators 3 and 12. We have our standalone variable. We have our do while, that is the main loop of our program, which allows us to keep iterating through this. We execute our main screen, and once we hit our first screen, if we don't hit the F3 key, we continue on and decide if we can go to one of our screens. And if the user enters something that wasn't a valid entry, it'll go to other and tell the user that they didn't enter a valid entry. I didn't really show that, so I might as well area solver nothing. It says invalid entry. Can't enter that. Okay. And then we end our select. Once we end our select, we also end our if statement. And then we're at the end of our do, and we check to see if the user hit F3. If they did, we turn on our last record indicator and we return control. Underneath our main section, we have, I should label this and say main, but it's all right. We have our 3 subroutines, which can get called and perform a specific section of code. And so this is also another reason why subroutines are so nice, that it makes our main section so much neater and nicer. It kind of shortens it, and it doesn't lengthen our code, because this could be, it could be something like 10, 20 lines of code. And once we have that multiplied by however many shapes we want, it's going to make this very lengthy and difficult to look through. This way it's very orderly and it looks nice and it's easier to work with. If we need to see what is in here, we could do something like Control F and go down to see where it is. Or I think you can also even go to definition, something like that. Anyways, so that's kind of all I wanted to go through. That is kind of the basics of interactive application, and this is kind of how you can set that up to traverse through your screens. So yeah, that's all I had to say.